Okay, in this final video, I wanted to look at solving a quadratic inequality. So you know when you found what caused x squared minus 4x minus 5 to equal 0, you either would factor or use the quadratic formula. This one factors, and you found that the x-intercepts were positive 5 and negative 1. So you knew that your quadratic function would cross or would have x-intercepts at 5 and at negative 1. And this one opened up, right? And then the other one, when we looked at finding x-intercepts there, with this particular one, the square root method worked well. So you took away the 8, then you divided by negative 2, which gave you a positive 4 on the right. And then you came in and you square rooted both sides and wound up with x plus 3 equaling 2, or x plus 3 would equal negative 2. So you came up with an x-intercept of negative 1 and an x-intercept of negative 5. Okay. Now this one then you knew would have x-intercepts at negative 1 and negative 5, and this parabola was going to open down. So this one opens up, okay, this one opens down. All right, now what I wanted to talk about in this video was, well, if they asked me for where is x squared minus 4x minus 5 equal to 0, I would say the solution would be right at negative 1 and 5, at those two values. Okay, and over here, if they asked, okay, where would negative, and then the quantity x plus 3 squared plus 8 equal 0, that's what the x-intercepts are telling you. So we already did all the work, and we know that would happen at an x of negative 5 and negative 1, okay, those two spots, right? But the question really is, well, what if they wanted to know where was this bigger than 0? Or maybe they'd want to know, okay, where was that going to be less than 0? All right, so they might want that, or they might want to know where is this right here. Going to be maybe less than or equal to 0. They might want a question like that answered. Okay, so when you get to a problem like that, what really helps is to realize you've got all of the information you need right here in this picture. So if you kind of think about the y equals negative 4x minus 5, it was a parabola opening up. The graph actually shows you where your parabola is greater than 0. That is, where is it above the x-axis? And and if they want to know less than or equal to 0, that's where is it below or on the x-axis. You can actually do this without a lot of algebraic work, because you can tell that if you pick an x value over here at, say, 6, you have to go up to hit the function. So your function value is positive. And if you go over here at, say, negative 2, okay, over here at negative 2, you have to go up to hit the function. So the y value is positive. But if you pick 0 or 1 or 2 or any number in between those two, you have to drop down to get to your y value. So you know that's where the y values are less than 0. And that's what this means. Greater than 0 means where is your y value positive, which is above the x-axis. Less than or equal to 0 means where is it negative or below. So I think it's a really good way to do it. You also can use test points, and I'll show you that in a second. But I would just look at the graph, and I know y is bigger than 0 here, y is less than 0 here, and y is equal to 0 when you're on the x-axis. So your answer to where is it bigger than 0, here's where the function is above the x-axis, and that happens, they want to know the x is where that happens. That happens for x's from negative infinity to negative 1. and then union that with from 5 to infinity. So that would be your answer to that question. But then in one problem, you have the answer to where is it equal, where is it greater than. You also can tell where is it less than, and I'm asking for less than or equal to. Okay, so can you see how it dips below the x-axis there? So that would have, the answer to that would be when you're in between -1 and 5, including the endpoints. That's where you're below or on the x-axis, and that would be the answer to it, okay? All right, now same idea here, it's just this one open down. So keep that in mind. So if I wanted to know where it is equal to 0, there we have it. But I could ask you questions like, okay, well, where is this one? Maybe I want to know where it's bigger than or equal to 0. Don't have to do really any algebraic work. If I can see that that's going to happen, I can see that here's where the y's are greater than 0. This means you want to be above or on the x-axis, and the graph actually shows that to you. So you can see when you're between -5 and -1. So your answer to that would be from -5 to -1 inclusive, okay? Right. All right, now, what if I wanted, where is that one? Less than 0, same picture, and I can see that the function goes below the x-axis here. Well, that's where y is less than 0, okay? And so that happens when I have x's there or the x's here. So that would be from -infinity to -5. And from -1 to +infinity, and I don't want it to be equal to, so I'm going to use a parenthesis on those. And since there's 2 intervals, I'll put a union in between. Okay, so that's one way to tackle inequalities when you're asked to solve them. Okay, you also can do them algebraically. So let's say you didn't want a graph. That's not your favorite thing. And I'll just do one of these on each. So let's say they wanted you to solve where is x squared minus 4x minus 5 less than or equal to 0. And then we'll do where is this less than 0. Okay, we'll do those last two. And we're going to do them algebraically. So if you're doing them algebraically, what you do, first thing you're going to do is you're going to start with, well, where is it equal to 0? And then you would factor or use the quadratic formula. You'd go through all this work that we've done before. So we're going a little faster than we normally would. And we'd find out the 5 and the -1. All right. Then what you would do is you would think about just this number line, just the x-axis is all you kind of picture. And you know that when you're at -1 or at 5, your y value is 0 at each of those. Okay. So what you're going to do is you're going to pick like a number to the left of that, a number in the middle, and a number to the right. So you might see, well, what happens at -2? What happens when x is 0? And what happens when x is 6? So you might just make a chart. And you might think, okay, I don't know what's going on. Let me get rid of that for a minute. Let me try that again. So you might just make a chart where you're thinking, okay, let me see what happens when x is -2. Let me see what happens when x is 0. And let me see what happens when x is 6. And you would just plug those in to the formula you have and evaluate them. So that's 4 plus 8, which is 13, minus 5. So you get an 8 for your y value. Okay. When you plug in a 0, you get 0 squared minus 4 times 0 minus 5, you get just -5. And when you plug in a 6, 6 gets squared. And then 4 times 6 minus 5, you have 36 minus 24, so that's 12. 36 minus 24. 36 minus 24, so that's 12 minus 5, that's going to give you 7. Okay, 4 plus 8 minus 5. This one should have been the same as that one, so I'm pondering what I did wrong, and I found it. That's 4 plus 8, which would be 12 minus 5. That one should have been 7 also. Okay, but anyway, so what I found out is that when I plug a -2 in, I get a positive number. I get 7, I get a positive number. When I plug in 0, my function's negative. When I plug in 6, my function's positive. So I can do it purely algebraically, and then I go back and I look at what I was trying to do. I wanted it to be less than or equal to 0. So I look for, well, where was it negative? And I can see it was negative here, and it was equal to 0 here and here. And so it will be right there. So the answer would be everything in between -1 and 5, including the -1 and the 5. So that's kind of how you would approach it if you don't want to graph. But in my personal opinion, if you'll just superimpose a sketch of the parabola on that, you can get the answer to the question, or you can confirm what you're seeing when you do this algebraic work down here. Just a way to kind of confirm it. Okay, so I like to do the graph on top of it as well. Okay, so let's look at the algebraic solution to this one. So again, if we were trying to approach this purely algebraically, we would need to know where does it equal 0, because that gives me the boundary. So that was where we did the square root method, and we wound up with, 2 answers. We wound up with x plus 3 equaling 2 or -2, and that gave us 2 x-intercepts. One at -1, and then over here at -5. Okay, now we do know, looking at the -2, we do know that this would have opened down. Okay, so we can keep that in mind later. But if we're going to do this purely algebraically, what we might do at this point, okay, is just come in and make a chart. And what we would think about is, well, let's see what happens when we're over here at -6. Let's see what happens when we're somewhere in between these, like say -3, but it could have been -4, or you just pick any number in between. And then let's see what happens when we're over here at maybe 1 or something. All right, so you plug in those x's and you figure out what the y would be. Okay, so this would be -2, and then -6 plus 3 squared plus 8. So you work that out. This would be -3, which when squared would be 9. That gives you -18, and -18 plus 8 would be -10. So when I'm over here at -6, I'm going to get a negative number. Okay, let me do that in red. I got a negative number. I really know the answer to the question now. Okay, but I'm going to keep going. When I plug in a -3 for the x, I get a 0 squared, which is 0, times -2, which is 0, plus 8. I get an 8. That's a positive number. So when I'm over here at -3, it's going to be a positive number. The parabola is going to be above the x-axis. And then I'm going to come in and plug in a 1 and work it out. And when I do that, I get a -2 times 16. And -2 times 16, that's -32 plus 8. So I get a negative number. What is that? -24. Okay, so I'm going to have a negative number when I'm over here at 1. Okay, I'll be down here somewhere. Okay, so this was negative, this was positive, this was negative. Okay, so what you were looking for on this one, we were being asked, I'll write it again right here. We were being asked, where is this right here? And we wanted to know, where is it less than 0? And so it's less than 0 when you picked x's over this way, and it's less than 0 when you picked x's over this way. Okay, and you didn't want it to be equal to 0, so you're going to think of that like an open circle. So your answer would be from -infinity to -5, and then from -1 to +infinity, and you would have parentheses on those. Okay, and then what I'm saying is, if you'll kind of feel free to do the algebraic solution, but if you'll superimpose a sketch of the parabola, you can see that it goes below the x-axis here. So you get this right here without having to do all this work. You kind of see that. So it happens when you're out here and out here, okay? All right, so I just wanted to look at a couple problems where you were being asked to solve a quadratic inequality. Okay, so I'm going to post these quadratic videos for you.